talk. Thank you everyone for joining us and welcome to our panel looking at how nuclear energy might play a crucial role in the next stages of economic and industrial development. My name is Patrick Carter-Cortez. I'm a PhD student in nuclear engineering at the University of Cambridge, and I'm also part of Nuclear for Climate's delivery team. For this event, we will be looking at three themes of how nuclear energy can contribute to industry. The main focus will be how we can address the challenges of decarbonizing heavy industry. We will also look at how nuclear can help achieve sustainable manufacturing, and also what factors and barriers there are to furthering nuclear technology in industry. Each of these subtopics will be part of a broader comprehensive view that we'll have on the topic of nuclear energy in industry. I will now ask our speakers for today to introduce themselves. We'll start with Dinara. Please go ahead.
Hello, everyone. Thank you for having me. I'm also part of Nuclear for Climate grassroots organization, and we will be at COP as well. But on top of that, I'm representing today Anthropocene Institute, and we are focused on promoting nuclear technology and nuclear solutions to fight the climate change, promote economic development, and helps the society to live abundant life, which is quite different from what we've seen being promoted in climate change discussions. But we believe that every country deserves the same path of economic development, access to resources in terms of like food, products, technology, as what developed world already had. So with that in mind, this is what we're trying to share with the public. Thank you.
Awesome. Thank you so much. Now over to Peter, please.
Yeah, good evening. My name's Peter Bradley. I'm the Global Energy Markets Lead for the Urenco Group. We're a supplier of commercial nuclear fuels, uranium fuels, to the global markets of the existing and the future nuclear fleet. So certainly we support and actively promote the role that nuclear has, along with other energy sources, in a future balanced, decarbonised energy mix.
Awesome, thank you. And over to you, Emma.
Thank you. Good evening, everyone, and thank you for inviting me today to talk. So my name is Emma Vernon, and I work at the UK National Nuclear Lab, and my role is as Government Account Manager. My background is in fuels development, and basically my role is I look after the programmes that are funded by government, which include near-term and future fuels and reactor programmes. But also links into the wider end user projects such as nuclear-enabled hydrogen and skills-based development programmes. Just a bit of a small intro into what NNL does. We are the UK National Lab for Fission, and we tend to sit in the area between the industry and academia to bridge that valley of death and to try and enable the technology to be brought through to applied solutions and to be commercialised by industry. We have a number of focus areas, including clean energy, but also medical radioisotopes as well as the decommissioning and the safety and security and safeguards. And our purpose is really that we stand behind is developing nuclear to benefit society through science.
Amazing. My PhD is actually partly funded by NNL. That's a fun fact. Moving on. So today's talk will have a specific format. I've just changed slide. Could you just nod if you can see the change? Awesome. So the format for today is we will split the talk into 3 rounds, each covering a unique theme. There will be a poll to start the conversation where we encourage the audience to participate. And then if you have any other questions or follow-ups, we encourage you to put them in the Q&A section of Teams, and we will get to that after we've covered the 3 themes. Okay, so let's get started. Why is decarbonizing heavy industry important? Well, part of the problem is that the global energy consumption a big chunk of it is electricity, and then there's an even bigger chunk that is industrial processes that are very hard to decarbonize. And many of the technologies suggested for decarbonizing, like solar or wind and nuclear, require materials that require manufacturing. And so this kind of couples the problem of you need a lot of new materials, but how do we get those materials without clean energy? That's why this topic is very important. Before we start with the polls, Emma, do you have any initial thoughts on why decarbonizing heavy industry is important?
Thank you. Yeah, I mean, I think obviously in terms of the percentage, as you say, of the utilization of the heat, particularly requirements, which then in turn is normally sort of supported by the fossil fuel end of the scale, because a lot of these technologies, as you say, have a requirement for high heat to deliver, and very few industries can deliver that. You're talking at the 800 sort of scale. It's not something that it's a lot of the practicalities, and that's where I think where some of the challenges are, or that they can't be electrified as well. So yes, I think it's kind of how do we get to that?
Interesting. I remember, Dinara, you mentioned that your organization has kind of a global focus. Is there an element to that into why decarbonizing heavy industry is important?
Yes. First of all, the heavy industry is responsible for almost 1/4 of all the emissions that we generate. So that's a large pile to clean up. Second, at one of the conferences, there was the Verge conference last year, there was a topic of cement production. And cement is widely used for our transition. We need cement for a solar panel to put them in place and have the base for them. Same for wind. And another part is housing. Like, there are millions of people who are unhoused right now or live in houses that are not resilient for climate change, for climate extremes. And within the next 20 years, we will be expecting that the demand for housing will be growing, maybe doubling, tripling. And the cement fraction of it will increase by the same factor, just because we want to have proper houses. And especially in developing countries, again, there are many houses that require complete, well, some communities require new housing where they can properly live in the weather extremes. So that part is really something that is global. And at the same time, the transition, how we see it today, it will require more materials such as aluminum, which also requires a lot of electricity and energy. Steel production, which is another, we have, nobody thinks about this, but we need so much steel to support transition. And copper, all these materials, they require high heat and constant supply of electricity. And compared to civil electricity supply, when we talk about the heavy industry, they cannot shut down in the case of blackout. They usually have backup generators or some additional supply sources, just because their margins are so thin when it comes to manufacturing, and they cannot afford to shut down the plant because of the blackout and then ramp it up again. Just because of those factors, we will need to support heavy industry. And there are other processes that we can decarbonize, like mining is another very CO2 heavy sector that will help, that helps and supports all the activities I mentioned before. And at the same time, it requires a lot of energy, a lot of processes need to be decarbonized. And just having that holistic view on the scope of work we have, it's a lot of work. And that's why decarbonizing heavy industry is so important.
Absolutely. No, and I think you've touched on many themes that we'll come back to in further down in this talk. So thank you for that. Peter, what are your initial thoughts on the importance of decarbonizing heavy industry?
I think my key message would really be about the scale of the challenge that we face. People very readily think about the decarbonisation of normal electricity grids, and in most developed economies, electricity grid consumption is around about 20% of total national energy consumption. Of course, the vast majority of that 80% is consumption of the transport fuels, for planes, trains, automobiles, cars, all of that sort of side, as well as domestic and commercial heating, and of course large industrial heat applications for major process plant is a big slice of that. So finding solutions that can deliver not only the types of temperatures that heavy industry need, but the sheer scale of the energy demand that is out there from heavy industry. It's a very big challenge, both from a reduction in carbon emissions, as part of decarbonisation goals, but also just as supporting the economic prosperity of developed and developing nations, because quite frankly, heavy industry adds value to economies, and economies pay for public services and for housing and for governments and other things that support well-being in societies and communities.
Absolutely. And I think that when we talk about sustainable development, I think in many contexts, it's development first, sustainability later. But if you can do both at the same time, then that's really the goal that everyone's after. So with that thought in mind, let's get started with the first poll question about the revolution in energy that we need in heavy industry. So we have two questions. What are the key challenges for industrial decarbonization? And how can we reduce embedded CO2 in industrial processes? So let me get the poll open, and then we can have our audience participate. And also you three, please feel free to take part. Okay, so poll should be open. First question, what are the key challenges for industrial decarbonization? Can I just confirm that the poll has appeared on screen for everyone? Well, I don't seem to have many results coming in.
I just responded, so did you see? Maybe there's
No.
some problem on our end, on like Teams.
Potentially, it says the poll requires being signed in. So I do apologize for the technical issues. Mhm. It does not accept responses from guest join-ins. I see. Okay, now I see some results. There's probably a lag there. Right, so the first question, what are the key challenges for industrial decarbonization? I don't know if you can see the results, but 43% indicated high initial capital costs, and then that was the main one. So let's start with you, Peter. What do you think about these parameters, these answers that we suggested, low margins, 24/7 requirements, and the one that was most popular, high initial capital costs?
Yes, I think I do recognise those. I think the high capital costs for all of the sort of low carbon technologies, and by all of them, I think are the big three of wind, nuclear, and solar. Across all of those technologies, by definition, they're a technology that does require upfront spending to put an asset on the ground, but of course then with very low or near zero operating costs and low fuel costs throughout their lifetime. You invest in a long-lived asset, but that could give you many decades of good service of provision of power. So it is the sort of cost issue is very much dealt with by the financing of the upfront capital for any three of those technologies, and that's very much the development model that we've seen. So I do agree that developing finance models, developing incentives for investment in wind, nuclear, or solar. I think all three of them are absolutely vital, and it's also incumbent on all the industry. I know we're sort of talking a bit more about nuclear, but it applies to all three of those technologies. It's incumbent on the developers to find the paths to be most efficient with the overnight costs of building any one of those assets. So the industry has to take responsibility itself and help itself become more capital efficient.
I see. And in that vein of thought about capital efficiency, Dinara, what do you think, what industrial process do you reckon would be the easiest to decarbonize, as it were, and which one do you think would be the hardest nut to crack?
Oh, so yeah, I've been exploring some of the industries like cement industry during one of the coursework at UC Berkeley, from the perspective how to bring the innovations and make it more carbon neutral. So one of the key challenges again is that they already invested so much into infrastructure. They want to use it as much as and as long as possible, and innovating it, that's one of the challenges, like from which angle they should approach, because there are a lot of buzzwords around the innovation in decarbonization and using AI, Internet of Things. So probably that's why they get super overwhelmed in terms of like where we should start with, where we should allocate our own resources first, which is a tangible challenge that we can solve quickly. And in terms of the role of nuclear there, it's first of all, it's problem on our end, I guess, on how to make nuclear accessible for those industries as well. Like the size matters, the location matters, because again, siting is not uniform yet. We have to basically prepare the environmental assessment for every single site, and it's kind of not every site will be suitable. So with that in mind, we also have to be understanding on it. Like we cannot decarbonize everything with nuclear quickly. And industries that might be easier to approach, as I mentioned, aluminum industry uses a lot of electricity right now, as they use more like electrical process, electric supported processes to melt aluminum, to make goods out of aluminum. So that's one is heavy in terms of right now the share on the carbon intensity, but at the same time, that might be one of the easier way to decarbonize that particular stream of manufacturing, just providing electricity. In terms of heat, again, not every heat will be suitable. We need high heat, so we don't have many reactors that can provide the heat higher than 600, 700 centigrades. So with that also limits what particular reactor concepts will be suitable. So we're working with limitations and we're working with the solutions. So I think that should be kept in mind. And for industry in particular, we need to set specific strategy on how to decarbonize, taking into account those boundary conditions we have right now. Maybe we will have more players in the next 5 years who will be specifically targeting industry with more startups than we have right now, because we know that the Dow and X Energy, they started interacting, and that's a very good signal for the market. But we see that, I mean, X Energy probably will be overwhelmed with all the all the requests and the orders once it will be mainstream and fully accepted. So that's another, I think, thing to keep in mind. We need more players on the market and more robust supply chain for those reactors.
Interesting. And Emma, in this line of thought of high initial capital costs as a challenge for industrial decarbonization, what role do you think startups will play in this? Because I think, if I'm not mistaken, NNL had some ideas on startups, or I might be wrong.
Thanks. I think, yeah, I mean, I think obviously an awful lot of the premise behind AMR and SMR, the challenge, or why they've come to the fore, is really around that high capital cost and investment ability, I think, as well. So I think that's some of the areas where it sort of opens up that market a little bit more through that sort of approach. And also, I think it's thinking of things. It's innovation is not just in technology. Innovation is how we do things. So how do we regulate things more sort of quickly? How do we make sure that we've got that ability to maybe start construction of one particular unit whilst moving on to whilst finishing the next unit? So you've got multiple kind of streams, or you've got streams of income, because that high capital cost is also inhibitive in terms of risk to investment. So it keeps the market quite small. And as Dinara was saying, we need that kind of competition element as well, that's sort of bringing more people, allowing more people to come to the fore as well, through different technologies, different approaches. I think that's kind of important as part of that high capital sort of barrier as well.
Interesting. So moving on to the second question, how can we reduce embedded CO2 in industrial processes? The most popular answer was process efficiency to reduce energy usage. Does anyone want to start the conversation on that one?
Yeah, I can say a couple of things around the use of small advanced reactors in this area. I mean, embedded CO2 really sort of breaks into sort of two categories. The first are the emissions from normally burning gas as an energy source, as a fuel in the production process. There's also significant emissions actually as a process emission, not a fuel combustion emission, particularly, for example, in dealing with calcium carbonates and dealing with cements and metals processes as well. So we have to recognise that decarbonising your power supply only goes a certain step. There'd still be some fundamental process innovation in that chemical or physical process, that metals process itself, in order to eliminate those process emissions. So certainly small reactors, advanced reactors, where we're moving from generation 3 to what we call generation 4 reactors. There's some, certainly they're progressing well. X Energy is one, but there are many reactors out there, high temperature gas, lead cooled, salt cooled reactors, as well as the more traditional water and boiling water reactor types. I think the concept of small scale, and by small could be 5, 10 megawatt electric, maybe 20, 50, those kind of sizes, they're really very useful technology in co-locating with existing industry that can feed those temperatures and the heat and the power, and indeed using excess as demand floats up and down, using excess to produce hydrogen to ensure that the reactor stays fully utilized, even when the process demand might fluctuate and vary day to day and hour to hour. I think having a base load source of heat, fundamentally heat, that's then can be flexibly used across power, direct heat use, and then hydrogen manufacture. I think that's a great concept and a great model where you can keep really high utilization of your nuclear asset that was expensive to build, even the smaller ones, and therefore you get the best capital efficiency because you're building an asset and really making it work hard and keeping it highly utilized. So I think that combination of heat, power, and hydrogen, I think, is a really important factor on deployment.
Brilliant. Well, we've touched on manufacturing a fair bit, so I want to move on to the second theme, and we can continue this conversation with that lens. So it's nuclear's role in sustainable manufacturing, and the question that we have is, what is the biggest advantage of nuclear energy specifically in sustainable manufacturing? So Dinara, I know you said that not everything is going to be nuclear, not every decarbonization effort will be nuclear, but what do you think is the biggest advantage of nuclear energy for sustainable manufacturing?
So again, going back to embedded CO2, and that's where the sustainable manufacturing plays a big role, is that once you emitted that CO2, it just stays. I mean, it's like if you were able to account how much CO2 you emitted during manufacturing of our renewable sources of energy, for example, that's just one example of housing, of any systems, it just stays emitted. You're unable to make it more efficient because the product is out there. It's an end story. When we talk about use of nuclear, this is the opportunity for us to actually remove that additional CO2 or remove the CO2 from all carbon emissions, some other contaminants that get released during the fossil fuel use. But we are able to remove those embedded contaminants or embedded emissions from the end product manufacturing. And I think that's the beauty of it, because nuclear power plant, it can extend it, we can extend their lifetime in case if we license it with one time, but then we're still exploring how long they can actually stay and produce clean energy. Second, clean energy sources such as solar, wind, batteries, we haven't produced any of them from other clean energy sources, just because, again, we mentioned we need high heat and constant supply of electricity to support the processes to make those technologies appear in the market or be released to the market. So as of now, we don't have sustainable way of producing the sustainable energy sources, just because we don't have like the circle is not yet closed at this point. And second, I think nuclear could play or advanced nuclear and general nuclear can play a big role in recycling the materials, because again, that would require a high energy and high heat demand to those processes. And right now, in many cases, in many cases, unfortunately, those processes and recycling are not economical. Again, I'm talking about the green energy sources that end up in a landfill in many states, at least in the United States. And I know in Europe, they try to push more robust regulations, but still we didn't reach the high level of recycling of many products yet. So this is where I think advanced and conventional nuclear can play a bigger role, supporting those recycling activities to make our life more sustainable, especially in the world where the consumption is high, the development of different technological advancements is high, and this is how we can do it quickly and economical.
Brilliant. Now, Peter, could we zoom in a little bit from nuclear in general, focusing on SMRs? In what ways do you think SMRs could be integrated into manufacturing operations, both in developed countries like the UK, but also abroad in developing nations?
Yeah, sure. I mean, I think the key point is their absolute low cost. So when you've got investments that are measured in the tens or the odd 100 million, not multi-billion investments, they're affordable, and they're of a sufficient scale. I mean, some of them are as small as footprints that could be sort of around 30 by 30 meter footprints, to something that's relatively easy to almost directly swap out a gas-fired CHP type of facility, where you're effectively just getting heat from gas and putting it through a turbine and producing heat, any combination of heat and power that the process needs. Just taking, quite simply, you have a uranium fission reaction producing heat that goes through a turbine and produces heat and power. So, these units are compact, they're very land efficient, they're much more affordable. They've got relatively low operating costs once they're built. I think someone else mentioned in the chat about how small the emergency planning zones are getting. Some of the designs are even maintain their emergency planning zone within the building of the own facility. So effectively there isn't an emergency planning zone outside the facility. And particularly when, in terms of community acceptance, where there are large industrial sites, both in developed and developing nations, with metals plants, refinery, process plants, cement, even large-scale food manufacturing as well. These are areas that are not naturally residential areas. They're quite naturally developed brownfield industrialized zones, particularly on the edge or away from large towns and cities. They tend not to be in the middle of large concentrations. They're very suitable, and many of these reactors don't have large cooling water needs that need either a large river or a coastal location. They're free of the restriction of deployment locations. So I think, provided government policy is really supportive and there's sufficient safety regulation, and really importantly, community acceptance. We do recognise as part of the nuclear industry that our license to operate comes from the community as much as it does from governments and regulators. It's really important that we engage well with nearby communities and residents, and that they see both the carbon and the economic benefits at a local, regional level, as well as a national economy level.
Brilliant. I just want to double check if Emma's still with us. Emma, are you there?
Yes, I am. Apologies, I dropped off a bit, but I'm back now.
No worries, that's all right. I wanted to get your perspective on this. What do you think is the biggest contribution nuclear energy can do to sustainable manufacturing?
Yeah, I think we've touched on a lot of it already. It so much is swapping out from existing fossil production. So I think that's really key. I think there's the sustainability is also around the multi uses of the outputs, particularly for the some of the newer reactor types. But it's that joined up approach of as a fit into the whole nuclear whole energy scenario. So for me, it's also not just a direct if you like, electrical outputs or the heat outputs. It's then how does the hydrogen generation from nuclear as a nuclear enabled hydrogen, how that then feeds into things like cement manufacturing, or sort of the on the chemical the high-end chemical processes as well, which hydrogen can really start to, or synthetic fuels can really start to increase the sustainability of some of those harder to reach industries as well. So I think that's where it's not just it's the direct, but it's also the indirect approaches that we can look at.
Brilliant. And in that line of thought, we asked in the poll what industries could benefit the most from integrating nuclear energy. And well, it's quite a even split, but many people agreed with Emma on hydrogen production. I think that's been quite popular. I do have a question. This is kind of like a personal question that I've had for a while. Why is it that hydrogen, nuclear hydrogen cogeneration hasn't really taken off? What are your thoughts on that, Peter?
I think that hydrogen production has really started from the reformation of methane, as a sort of the most mature production technology. Clearly it's great to start off and kickstart the hydrogen industry, but I think that its continuous reliance on the hugely volatile price of gas and the need for carbon sequestration and a carbon sink that's practically available in that location. There are not many places around the world, around economies, where there is a readily available sink to put all that carbon. So I think that electrolysis technology is really moving on fast. Traditionally, people have dealt with alkaline and PEM type hydrogen electrolysis. Solid oxide electrolysis is really developing on now. Because it runs at a high temperature, it's more suited to advanced reactors that can not only deliver the power, but deliver preheated steam, potentially up to 6-7+100 degrees C. That helps the efficiency of the hydrogen production. So you're just using less kilowatt hours of electricity to produce the same kilograms of hydrogen. So I think in terms of your question of, why hasn't hydrogen production by nuclear really got up there yet? I think the reactor types that are best suited are not quite on the market yet. They're still in development, and all the existing nuclear fleet that's out there is very much in demand for grid electricity. They've really been consumed in the electrical grid of today. So I think it's it really is a big economic opportunity for the nuclear industry to technology couple itself with the hydrogen technology and be able to produce, on a single site, have uranium in the front of the process and hydrogen out the back of the process, and there's not there's no direct carbon molecules in that process anywhere. So that's I think a great advantage. We still need to prove that we can develop it, and we still need to prove that it can be done economically. So there's technology development still to be done, both on the nuclear and on the hydrogen high temperature electrolysis side. So I think great opportunity. We're just a few years away from that.
Brilliant. And Dinara, previously when I asked you what the low-hanging fruit of decarbonization industries would be, I think you mentioned cement and aluminium and steel production. What lessons do you think could be learned from those industries being decarbonized that could be applied to hydrogen production, for example?
Hard to tell, because those industries have been on the market for centuries, probably. Well, for decades for sure, and some of the industries for centuries. So we know how to make steel since many years. And there were lessons learned within the industries. For hydrogen, it's such a new niche, and that got so much popularity because of the way we can actually utilize it once it becomes economical. So I don't know what the lessons we can apply. I guess how to make the process more efficient, taking into account that technology changes, and think about not what we can potentially do to get the hydrogen, but see whether we can make it economical in current conditions. So and also think a bit more creative in terms of using nuclear as well. Sorry, my dog seeking for attention. If you hear him barking, sorry. But I hear a lot of rhetorics on making nuclear more adaptable for renewables, basically ramping up, ramping down on demand, which I think is a waste of nuclear, because we want nuclear to run 24/7. It's the biggest advantage. And instead of asking a nuclear power plant to ramp up, ramp down on demand, to collocate it with renewables and make some kind of adjustments, like when we have a peak of solar production, let nuclear produce hydrogen, because again, we might not need to produce hydrogen 24/7 as of now. But maybe use that kind of approach to think about future infrastructures, how we can use the best features of one technology to make it beneficial for entire economy. With this in mind, I think that will be more beneficial to like put together three all clean energy sources to kind of mitigate their losses and make sure we take the full advantage of all. And in this scenario, I think that will be the most economical. And that's a lesson learned, I would say, from some other industries, from power generation, when we know that we can use water as a storage. When we have like high electricity production, we kind of bring water up, and then during the low electricity supply, we can use the water to supply hydropower. So that's not from the industry, but it's from power generation, when we can kind of play around the existing infrastructure and plan the future infrastructure to make those beneficial solutions. And yeah, with that, I have to stop.
No, thank you so much for that. We'll move on to advancing the adoption of nuclear technologies. So the question is, what do you think smart infrastructure will be like in urban spaces? And what do you think the biggest barrier to collaboration in nuclear technology advancement is? So which factors are most crucial for advancing nuclear power industrial solutions? The most popular choice selected was government and public support. And I think, Peter, that's something that you touched on. So my question for you is, how have public and private partnerships facilitated the advancement of nuclear technologies?
Yeah, government plays an important role in developing technology, both from a national policy point of view, as well as providing business models to support early investment. I think the alignment of international safety and security regulation is another important area. The economics of small-scale reactors, particularly when we talk about SMRs and AMRs, the modular, the concept of being factory built, so a single or very small number of global locations where a business would be volume manufacturing these, and it's something equivalent perhaps to the manufacturing techniques used by the civil aviation industry, where they're making tens perhaps of large capital units a year of a particular type, a large aircraft, these types of capital goods. The international harmonization, just for example, of international aviation standards, is a really important factor, such that you can be sure that your Boeing 787 is approved to land at any airport in the world, pretty much. So if a reactor developer is developing to appropriate safety standards and to engineering integrity standards, and that's proven through quality assured through manufacturing, having a way that whilst it's very hard to fully align international regulatory standards across all countries, because it's a sovereign right of each nation to govern its own nuclear industry, having sort of some greater element of cross recognition of the work that different regulators do. There's certainly recognition between US and Canada, between US and France and UK, between UK and Japan, for example. There are a number of sort of bilateral recognition agreements, I think furthering that such that developers can really help get costs down for the benefit of everybody by building a single unified global design. It's like the the classic Toyota Corolla that Japan might build to sell equally in every car market in the world. Having a single design that everyone accepts, then you can make lots of it cheaply, and that really benefits everyone and brings cost down.
It's very interesting. Emma, same question for you. How have public-private partnerships facilitated the advancement of nuclear technologies?
So yeah, it's as we've said, it is quite an interesting one in terms of the public-private partnerships. It's something that in terms of what the lab tries to do is to work with a variety of bodies to help drive those sort of different technological advancements, and also bring together different industries as well, because I think there's an element as well of that particularly around collaboration. How do we maximize that collaboration? So it's outwits, I think, of just the nuclear side of things. It's bringing together organisations that from for example, from the chemical industry to sort of look at their innovation as well, to drive those advancements, and there's been sort of some success, particularly sort of we've had on fuel manufacturers through that, but it's very much that valley of death. So it has to be, as it says there in the title, in the name, it's like it's the partnership part of it. It can't be driven on from one side alone. It does need that support. I think obviously we've touched on the regulatory side of things as well. I think that's part of, and government as well are also part of that partnership and that collaboration, because there isn't if the answer was simple, it would be there now, and I don't think it is, obviously. So I think it is those, how do we work together on those collaborations, and thinking smarter about how those collaborations can be put in place to make sure that the advancements that are needed are happening, and be that through commercial routes or through academic routes, or sort of a variety of different mechanisms, I think, and we have to consider those as well.
Brilliant, thank you. Dinara, my question for you is, there was a survey that we did at Nuclear for Climate on mapping the nuclear landscape as it is right now, tapping into the network of Nuclear for Climate across the world. And we actually found that the number of people working on cogeneration projects or renewable and nuclear complementarity, which are things that we talk about a lot in our advocacy, is very low. Why do you think that is, and what could be done to address that?
I think one of the issues is that there is no innovation on how we're going to sell the electrons, because in the renewable sector, they've been applying new financing schemes to kind of make a agreement between the end user, or like the end off-taker, and the renewable supplier. Second, the tax credits to renewables, they were available for much longer. And in the United States, the IRA just got released like last year, which provides some tax credits for nuclear use. So I think there was a gap between how we can really apply the same scheme for financing and for off-taking nuclear energy compared to renewables. And I think that was a gap when we were like probably unaware how we can use it really, because nuclear is perceived as something you just have to invest a lot of capital, and you're taking the risk of probably on getting it not on time or not on budget. But with renewables, usually there is like owner and operator in one place, and they sell the electrons. So with SMRs, I think there is an avenue, because the reactors are smaller. The manufacturers can also ensure that they are operators and manufacturers, and they can sell electrons. In this scheme, it will be easier to think about a co-generation and co-allocation of those projects, so they would have similar financing structure, more understandable for the off-takers. That's my opinion. But also there was a bit of a pushback from industry, like renewable industry itself. They were kind of looking at the market as something they want to own, and didn't really perceive nuclear as needed. But now we see more and more that without the base load, it's really hard to achieve the result we want to achieve. And it's not a competition per se, because we have quite, like, nuclear has quite different role, renewables have different role, and together we can decarbonize quicker. But that was not a rhetoric, and still is not a rhetoric for some of the producers of solar plants, wind turbine plants, because they see a nuclear as a competitor. So that might be another reason that explains why we have so little research on that area. But I would like to see more, and I would like to see the real projects when we can have those opportunities implemented. And I think the first step and first announcement was from Constellation, not on collocation, but more like using the nuclear to host the hydrogen hub, which I think also gives the signal to the market that if the big utility with the biggest nuclear fleet commits to this and ready to supply electrons to produce, well, supply the resources to host the hydrogen hub, and got the big grant to do it, and ready to use nuclear fleet, that's one of the signal where we can start co-locating several capacities to produce some green solutions. And in the future, we might think about co-locating the renewables to, yeah, as I mentioned, to produce the goods during one time of the day and then electrons to the other time of the day.
Brilliant. And that takes us to the final question, which was, what do you think is the biggest barrier to collaboration in nuclear technology advancement in industry? And the most popular choice was lack of support. That was something I think, Peter, that you touched on. What can the nuclear industry do to bolster public support for nuclear in decarbonizing industries?
I personally do think we are making good positive step forward in that area. I think quite uniformly, directionally, there is increasing public support for nuclear, and there's recognition that nuclear is unique in the fact that it is the only technology that is available for the foreseeable future that has the combination of factors of being low carbon, adding to energy security, and helping to de-risk the price of energy in the future. There are 3 points of a triangle that many have called an energy trilemma in the past. Managing energy security, managing decarbonisation, and managing affordable cost. And they're all linked to the UN SDGs, of course. I think we are making positive steps forward. I think particularly in the last few years, since there's been more conflict in several areas around the world. I think the topic of energy security has become much more prevalent in the news and in public consciousness. And we are making steps forward. I think there's much more that the nuclear industry can do to provide reassurance on safety and security and safeguardings of fuel and materials and control of technology. So there's certainly more public information that needs to go out there, and there's more there's more communication, at an industry level, but also at a total public level as well. So I think it's just being transparent, it's being open, it's being honest with what nuclear can and can't do, because it isn't the perfect answer to everything. So I just think that continuous, open, honest communication is absolutely the best way forward, and trusting and listening to what people say back to the industry too.
Interesting. Now, another potential barrier to collaboration between nuclear and industry, so cogeneration, etc., is regulatory challenges. Emma, in the UK at least, in that specific context, what challenges could there be citing cogeneration, say nuclear and hydrogen or nuclear and steel manufacturing plant?
So I think it's a lot of it is kind of assumption based. I think that it's not been tested as yet with regulators in terms of that siting, because obviously in terms of the UK, regulators tend to assess what is brought to them, and so I think there's a piece there as we talk about educating or engaging with the public is the same with from a regulatory point of view. So really taking them on the journey as well, so they understand, you know, where the risks may lie and the benefits as well. Obviously, looking at new technologies, the risks are different from existing sort of reactor technologies assessments that they would normally do and safety cases they would normally look at. So I think from that point of view, it's an education on all sides. But I think there's a real opportunity to take them on the journey with us as we sort of move through those processes to really push and understand where those challenges really are, where the perceived challenges are, and how we can innovate against those as well. You know, sort of conversations that the UK regulators are having with new technology providers, new vendors, I think is really good. And I think it's a step change from that, them being involved at the end point by bringing them through the development stages as well. So I think that's key for me.
Well, speaking of new technologies, we'll move on to the Q&A section. And the question we have is, how is artificial intelligence being utilized within the nuclear sector? And how does this technology benefit the crossover between nuclear and other industrial domains? Dinara, would you like to lead us off?
Yeah, I don't have many leads on that, but I know there are a lot of efforts on creating digital twins for nuclear power plants, which have been used in different industries already, to basically predict based on certain metrics from like parameters to find out the key, or to find out where the problem is without shutting down the power plant and doing it quicker, more efficient. So I think there is one company called Metronome, part of Ramaton, that doing that right now. And another part is how do we make like key learning from all in the industry, nuclear industry, to apply it to better like user interface of the operation, operator's room of nuclear power plant. So I think there will be a lot of learnings we have from conventional power plants that can be applied. A lot of data collected during years of operating those power plants to make the user experience or operator experience more friendly, or more kind of eye friendly in terms of the way we can operate those in those rooms. So I think those are main AI uses I am aware of. But of course, we can still apply. We have so much data on operating the nuclear power plants, and that easily can be transferred into a model that can predict many challenges we might have, and that's in nuclear, I think addresses the issues pretty quickly. So with that in mind, I think we still have opportunities to learn, but it's like we just like address things super quickly.
Awesome. Well, we are running a little bit behind schedule, but Emma, your views on this. The question was artificial intelligence in the nuclear sector and how this can benefit the decarbonization of industrial heavy industry.
Yeah, I mean, I think obviously in terms of the AI, it's a new facet of the world. So it's how we kind of embrace that and move that. I think there's less from the decarbonisation, but more from the sort of plant operations. There's opportunities to utilise it to make things safer. So not necessarily having to send people into environments that would they would normally have to go into to do training, etc. They can use that, so the artificial intelligence through that, and virtual reality. I think there's a lot of application for it. As we said, the digital twinning as well, to optimize and maximize how we can utilize to run the types of reactors. I think that we're looking at now, I think, is something. There's a lot to learn and a lot of data that I think will come out as we move forward with some of these technologies. So yeah, difficult question to kind of pinpoint it against the decarbonisation, but I can absolutely see it as a facet of the industry going forward that really needs to be understood, because it's something that we haven't utilised to the best of its ability yet. But I think embedding it into the technologies as they move forward, I think is key to making things more efficient, safer, and also just sort of better, sort of in terms of delivering the needs that we want.
Yes, and I guess ultimately AI is a tool, and if nothing else, it will just help with licensing. Peter, your views?
Yeah, I think perhaps the additional area I'd add to that is more of a sort of total network system optimization view. As we've traditionally come from a place where electricity grids, were fed by a relatively small number of large fossil fuel plants. We're now having electricity grids which still have a number of large-scale single-point feeds into the networks, large nuclear plants, some large gas plants, obviously still decreasing number of coal, but also much more distribution, much more small-scale renewables, everything from domestic upwards, many more sort of grid-scale batteries distributed around networks. So trying to look at the totality of that, when nuclear is baseload, solar is quite predictably intermittent, and wind is unpredictably intermittent. I think there's a bigger and bigger optimization challenge of a total grid network as a single network solution, and I think that's optimizing both at an operational level and asset efficiency level, but also at an economic level, understanding how much baseload do we have, and when the wind varies, how does that change the marginal pricing of different sources? How do we marginal price demand and change consumer and industrial energy prices at different times of day to influence and adapt end user behavior, not just at time of day level, but in terms of the type of heat or power balances. So I think there's grids used to be relatively simple, a lot of fossil fuels in and some basic consumption, and now we've got such complexity building in the network itself, having different generating sources with different characterizations and much more distributed generation, as well as batteries. And this sort of, I think all of that, I don't yet know how AI is really going to help us in that space, but I know it's a data-rich environment. It's a multi-sensor point environment. It's a big optimization challenges, and there's huge opportunities to lower cost for everybody by using the synergy and the crossover of different assets in the most efficient way possible.
Absolutely. Well, on that note, I think that's a good place to wrap up this event. Thank you to Dinara, Peter, and Emma for sharing their insights on how nuclear energy can contribute to decarbonizing heavy industry. I also want to thank all of you for listening and participating today. I do apologize for the glitch with the poll. Technology always seems to get the worst in us. Wherever you are in the world, I wish you a very pleasant rest of your day. And remember, net zero needs nuclear. Thank you so much, everyone.